Hello, I am Ananya Palit and I am here to demonstrate the working of our course project in CSE 564 visualization course. In this project, I worked along with Souradeep Chakraborty, and we have worked to explore the computer science literature that have been published all these years. We have collected the data from mainly the DBLP database from 1980 to current date, which has around 2 million articles, and also from the Scholarly API to get data from Google Scholar profiles of the Stony Brook University CS faculty members. So we focused on mainly three things. One is the frequency of the title keywords that have been used all these years, and we postulated that the keywords themselves are representative enough of the type of topics that have been researched all these years, because the title carries the significant description of the paper. Yeah, so for that, secondly, we have done topic modeling using those keywords alone, and thirdly, we have found out the research correlation between any pair of CS faculty members from Stony Brook University, just again using the keywords of the titles of publications that they have. So let me walk you through this. In this first page, we show the frequency visualization of the terms. So in this word cloud, you can see that the word system appears largest. So this is the most dominant keyword that have been used all these years, followed by networks, probably the second largest here. Model, analysis, algorithms, yeah, these are the most commonly used words. So the overall frequency, the running frequency total, has been plotted in this bar chart here, and I've provided a slider here. This slider we can use to see how it was over the years. So in this graph, we've shown the top around 15, I guess. Yeah, the top 15 words all these years as a cumulative total. So the word system still was most popular back in the 1980s, and it's rapidly increasing. So you can see that the frequency, the scale here shows that the frequency of these words are also increasing very rapidly. So yeah, a lot of publications these years. So that finally we come around to see that systems, networks, yeah, these are the most commonly used words. One thing that this particular chart has been able to reveal to us is if you look at this word data around somewhere here, just at the start of the 2000s, it was the last of these 15. So over these years, it's actually increased in popularity. And if I scroll below further, it's around at just around say 7 or 8 here. And it's going increasing, going further below here. You can watch this data word coming further below, and finally around here. So uh, even further below, yeah. So by now the word data is very commonly used, and it's evolved in its frequency and proportionate frequency all these years. Same with the word learning. You can see that it's somewhere here right now, but just around here you won't even find this word. So I think it first appeared as one of those top 15 here somewhere around in 2011 here, and that probably represents that growing increase in the machine learning research. So it's going further below here. Yeah, so some keywords are more frequently used than others these days. So this chart has helped us reveal that. Finally, we've also plotted the co-occurrence matrix for these top 25 keywords. So this is by default sorted by the word algorithm, and the color here represents the co-occurrence. So the red means low co-occurrence and blue means high. So for example, you can see that the word say data. So data, yeah, this is the bluest here. Yeah, this is actually this is the one bluer. So this is the bluest. So it appears most with the word analysis. The word control here appears most with system. So if we look at the word network, okay, network appears with neural. Oh yes, the neural networks. They are very frequent these days. It's also with this one, the two blues here. It's a wireless. Oh yeah, the wireless. So yeah, the network actually represents two kinds of things. So wireless and neural both co-occur very well with networks. So yeah, this chart has been able to reveal all that. We can sort these by frequency, which gives us the more blue ones, the higher co-occurring ones on the top half here in this diagonal, above this diagonal. And we can also sort them by the cluster that they belong to. So let me now go into the clustering thing that we have done. This is actually the cluster of topics that they've been classified into, or clustered into rather. So let's go into the clusters. So this chart here, this represents the topics that the keywords have been clustered into. We have used the fisheye lens distortion on a graph to represent these clusters. So we can magnify the words as we want to. So this represents the cluster of topics between 1981 and 1986. We have done this clustering, topic modeling, all from 1980 onwards across the time with 5-year spans each. So let's go down to the latest span here, or say somewhere around 2015. Say this is the cluster of topics between 2011 and 16. We have used actually the latent Dirichlet allocation model on the bag of order presentation of the keywords. So these clusters can actually help us understand what kind of topics they represent. So for example, if you look at this one, this pink cluster here, object, image, detection, classification, technique, feature, novel, video, digital. Yeah, this represents the image processing and vision, actually vision, computer vision related cluster here. Similarly, let's see another one. So how about this mobile? It's a very thick cluster here. Distributed communication, mobile, scheme, efficient, sensor, wireless, network. So this actually, even neural comes here. So this actually is the network cluster. So the word neural actually has been clustered here. But if you go further below, in the latest cluster, you see the word neural is now in this other cluster of computer vision. And in fact, you can see that the word convolutional, representation, segmentation, um, deep, so deep convolutional, I guess, prediction, these words now predominate this dominate this cluster of computer vision related topics, I guess. Yeah, so you see that the keywords actually evolved in their correlation with different topics over the years. So this chart with this time varying clustering can help us to figure out where these keywords are more clustered around, which kind of topics they represent. So if you want to see more details of the topics that we have come up with, so we have prepared a dashboard. Here we will show the statistics of the different topics and along with something else. So let's see this dashboard. This chart here represents the number of articles by topic. Now here I've labeled the topics here. We have hand labeled them based on the keywords that were occurring as we found out. So we can see that the keywords alone are enough to show you the topics that they represent. So this is the machine learning topic, this is the algorithms topic. We can see that the algorithms topic has been the most researched area here with the highest number of articles, around, well, that's around 2 million here. This chart here represents the number of articles per number of author, actually the number of articles per number of authors. So you can see that most of the articles overall are co-authored by 2 authors here, a few with 3 authors, and then with single authors. So this gives us a unique insight into what the number of authors are for different kinds of papers. And this trend line here shows the number of articles per year, and you can see that it's grown super linearly over these years. So more and more research publications are made in the modern times. Now another thing here is the little data table here. This shows us some very say the top 10, I think the latest 10 articles from this set for our convenience. Now this is a dashboard, so we can actually filter data here, and we can change the data here. We can filter subsets, and they're coordinated across these 3 charts. So let's see some insights. So how about I select one of these topics? Say I've narrowed it down to vision. So vision is mostly, they have 2 or 3 authored papers. Yeah, that's okay. But one thing you can see that here in this trend line, this vision related research number of publications has suddenly increased. It's not just super linear, it's kind of exponential here around from 2015. It's just sudden spike here, increase here. So you can see that the vision related research is very rapidly increasing in these years. I think the same kind of trend you can see from the machine learning, slightly flatter. It's also very popular these days. But if you see something, say, related to software, it's more like linear, almost linear. So some areas are rapidly more researched these days. This is really exponential research right now. So also, how about this other research here? This is more flat. This miscellaneous is probably it's actually the cluster representing the topic of reviews, case studies. One thing here unique is this. In this cluster we can see from this visual query that single author papers are most here. In fact, here also it's more of single author paper, around 30,000 or more single author papers here. While here, yeah, it's even more here. So yeah, more case studies are done by single authors rather than 2 or 3 authors. In fact, it's actually growing exponentially lower suddenly. But this is not the case with this, say, networks related research. It's more 2 and 3 authors as is more common. So this we could see only with the dashboard. And now finally, let me take you to the Stony Brook University CS faculty research relationships. So here we have the same kind of correlation matrix as we saw in the first page. Red representing low correlation, blue representing high. We've sorted it by last name. We could also sort it by citation count here. So, and you can see that the numbers in the bracket actually show the citation counts for these faculty members. So for convenience, let's go back to this last name. So how about, let's see one by one. So how about Professor Mueller? So not really high here with this one is very whitish, so at least this is high. Professor Mueller mostly correlated with Professor Hong Xin, who is also a researcher in the computer graphics domain. And in fact, this one is even more. This is slightly bluish, so even more. So Professor Adi Kaufman. Yeah. So the correlation measure, you can see that it's 40 here. So this is very blue. Let's see this. Professor Ritik Banerjee and Professor Niranjan Balasubramanian. This is, yeah, probably that both of them research in the natural language processing area. So how about Professor Zadok? Professor Zadok, I think this is a whitish, yeah, here. Professor Michael Ferdman, yeah, both of them research on systems. So yeah, that's good. That's actually this we've done by collecting the data from the Google Scholar profiles using the Scholarly API in Python and from their websites. So you can see, and we've actually followed the similar kind of methodology. We've collected the keywords from their titles of publications, and we've done a correlation on those keywords, the co-occurrence of these keywords. So again, we prove that the keywords of these professors, the researchers, they again prove they are enough to show correlation in the research amongst people with similar areas of interest. So I think, yes, that's it from here. So I hope you liked our findings, and thank you for watching.